Okay, a car traveling 70 miles per hour travels 75 miles farther than a car that travels 60 miles per hour. Find the distance that each car travels. And it says that cars travel for the same amount of time. Now they throw in a bunch of stuff. Now here's what I want you to do. The only one of those formulas in the last sheet you're going to need is time, okay? Time equals distance. Time, I'm going to put distance divided by speed. And I'll explain why that's the only one you're going to need here in a second. Now you're going to make a table just like that. You're going to split it into two parts and you're going to make 4 columns out of it. Now here's how you label your table. You're going to put fast and slow. Okay? The fast car and the slow car. Right here we'll talk about the speed of each car. Right here we'll talk about the distance each car travels. And right here we'll talk about the time that they travel for. Just be consistent. Now let's talk about the speed of the car, okay? The speed of the car, you have 70 miles per hour. Miles per hour is what I'm looking for. So there's miles per hour and there's miles per hour. So 70 would be the fast, 60 would be the slow. Now once you put those in there, cross out 70 and 60. We don't want to see those anymore. Now the distance traveled by each car. There's distance is just miles. Well, I have 75 miles, but it says farther, okay? You don't know the distance that either car traveled, okay? You have no idea. You just know that when they stop, one of them's 75 miles ahead of the other. So to express that, what you're going to do, we don't know either one of these, so we're going to put X and X, but I know that this faster car goes 75 miles farther, okay? So I put plus 75 with that. Just leave that as X, okay? Now you can cross out your 75. Now the time it travels. Now you don't know anything about the time. You know that they're equal, so put equal. And you also know time can be expressed as distance divided by speed. Distance divided by speed. So look at your fast car. The distance we don't know, so I put X plus 75. Meanwhile, the speed I know that was 70. Now let's go down here. The distance I don't know, it's X, so I write X, and then the speed is 60. Now you're like, what do we do? Divide? No, you can't divide because you have X there and X there. What you are going to do is now make a proportion. Put an equals, and you're going to put X plus 75 over 70, and here you're going to put X over 60. Now line up your equals. Circle the diagonal. 70 times X is written as 70X. Now over here I don't just take 60 times X because there's a 75 with it. So put a 1 in front of the X right there and write 1X and 75 separately. And you're going to multiply by 60 and you're going to multiply by 60 again. Both of these separate amounts are times by 60. So that's what you did yesterday. So 60X. And then I take 75 times 60, 4,500. So on the other side of the equation, I write 60X plus 4,500. Now, you got two different X's, and that's okay, but get rid of this 60 right here. It's positive, okay? So you're going to subtract it, and 60X minus 60X is 0. Now I subtract over here. 70X minus 60X is 10X. And over here we got 4,500. Now I can just go ahead and divide because X, the only X I have is here. What's happening to it, it's multiplied by 10. So the opposite of multiply is divide by 10. So I divide 4,500 by 10 and that's 450. Put 450, you have the miles for the slow car, okay? Now go up in the table, cross out the X's and put 450. So I have 450 for the slow car, and this one I take 450 plus 75, and that tells me how many miles the faster car traveled. 525. Okay, so those are your two solutions. Okay, it's kind of weird, so we'll go over two more. A car traveling 85 miles per hour travels 200 miles further than the car that travels 65 miles per hour. Find the distance each car travels. Same setup. You're talking distance, speed, and time. So this is my fast, and this is my slow. So we're going to talk about their speeds. We're going to talk about their distance that they travel, and then we're going to talk about the time they travel for. Now the speed is in miles per hour. If it doesn't say, so I'm going to circle that because that says miles per hour. That says miles, but it doesn't say per hour, so we have no business putting that in there. 65, okay? 85 is fast, 65 is slow. Now get those out of the problem. Now the distance, okay? Distance is just miles. But I have 200 miles, but it's further. That means nobody actually stopped at 200 miles. That just means when they stop, one is 200 miles ahead of the other. So maybe one's at 500, one's at 300. That's 200 ahead. Maybe one's at 500, one's at 700. That's 200 ahead. Heck, maybe one's at 800, maybe the other one's at 1,000. That's 200 ahead, okay? So we don't know them. But what we get to do with the 200 is put plus, remember it's plus, because ahead would be adding, and it's the faster car, so 200. Get rid of that. Okay, now time. Again, time, and again, you're always going to need the time. Time is distance divided by speed, okay? So I make a division line. And the distance of the fast car we don't know, but we have a representation, x plus 200. The speed of the car we know is 85. The distance is x, the speed then is 65. And I know the times are equal, they stop at the same time. Same means equal. So I put equals, I put x plus 200 over 85, and over here I put x over 65. Now, I rewrite my equation. First, 85 times x is easy. That's an easy product to write. 85x, don't just put 85, it's 85x. This is a little bit more complicated because now it'd be 65x, but then also I got to take 65 times 200. So I'm going to put a 1 with the x, and I'm multiplying 65 times 1x, and then 65 times 200. So 65 times 1x would be 65x, and then 65 times 200 is a constant. It won't have a variable. It'll be 13,000. Okay, so put 65x plus 13,000. Okay, now you got two different x's, but let's get rid of the 65x. Get rid of your smaller one by subtracting. Okay, line up your equals, that's 20x, and over here you have 13,000. Okay, now the only thing that's happening to the only x I have is multiply by 20, so we divide by 20. So 13,000 divided by 20 is 650. Now go up in your table and substitute 650 for both your x's because you don't need the x's there. So you know you already have 650 written down for our slow car. The fast car we take 650 plus 200. 850. Boom. Okay, and the last one. One car travels 75 miles per hour on a trip while another car travels 60 miles per hour. At the end of the trip, the first car traveled 120 miles further. How far did each car travel? Same thing, they travel for equal times. Time equals distance over speed divided by speed. Now we're going to need that ratio later, as you saw with the first two. So I don't need the other two, okay, because I have something I can put in for represent the speed with what they are. Distance I don't know, but I can at least represent it. Time I don't know anything about, so I have to go to my distance divided by speed. Fast, slow, you got speed, you got distance, and you got time. Okay, the speed is in miles per hour. That says miles per hour. That says miles per hour. So 70 is the fast, 60 is the slow. You don't have to give that a second thought. Now, distance is just miles without the per hour. Well, that says miles. It doesn't say per hour, but it says further. That means when they stop, you don't know how far they travel, but one's 120 ahead. So these are both unknowns. But what I get to do with the amount further is I get to add 120 to the. Then you can cross that out. Now the time, again, I only know that the times are equal. They stop at the same time. But I know time can be expressed as distance divided by speed. So the distance is x plus 120 divided by 70. The distance is x divided by 60. Okay? So rewrite that in a proportion. Because the times are equal. Okay? They stop at the same time. So I got x plus 120 divided by 70 equal to x divided by 60. So now I'm cross multiplying, okay? 70x, that's easy to write. Over here, that's again 1x. You don't just you take 60 times x, but you also got a 120. So I place a 1 in front of the x, and I write 1x and 120, both of them separately. And I will be multiplying both of those by 60. So 1 times 60, 60. It's 1x times 60, so we put an x factor there. And then 120 times 60 is going to be 7,200. So over here, I write the expression 60x plus 7,200. Okay, so here's my equals. We got x's on opposite sides, so get rid of the smaller one. Okay, and you get rid of it through adding and subtracting. Okay, so you're going to not adding, you would subtract 60, so it would go away. And I have 10x over there, and over here I have 7,200. So now I divide by 10. 7,200 divided by 10 is 720. Okay, so go up here and take your 720s out, your x's out, and just put 720s in for both of them. So I have 720 for the slow, and up here 720 plus 120 is 840. So that's how many miles each car has traveled when they stop for the day. Okay, you have one problem. I will put that the time is equal to our distance divided by the speed.